Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 15th, 2026, just about 3 days ago. It introduces a framework that replaces random sampling with structured, interpretable actions, reportedly producing up to twice as many semantically distinct outputs as the best current baselines. The paper is titled State of Thoughts: Structured Action Templates for Tree of Thoughts. And as we'll see later, the ability to explicitly steer reasoning patterns has some really impressive implications for model explainability. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 illustrates the complete 3-step workflow using argument generation as an example. First, in step 1 at the top, the system defines explicit action templates. These range from structural prefixes, like starting a sentence with if or for example, to high-level content themes like risk and consequences. Next, step 2 shows the generation phase. Here, a controller selects these templates to guide a tree search, creating branching paths of reasoning where the model fills in the details after each prompt. Finally, step 3 covers evaluation. The system scores the outputs and analyzes which specific action sequences drove better performance, allowing it to steer future generation toward those successful patterns. Now, figure 2 zooms in on the execution loop itself, applying it to a debate topic about banning plastics. At the start of the process, the controller selects distinct reasoning strategies to explore, labeled here as actions like exemplify, causal, or conditional. The generator then writes the actual text based on these choices. For instance, the exemplify action forces the model to begin with, for example, while the conditional action triggers an if statement. In the final steps, the evaluator scores each attempt, pruning the weak argument in the center so the system only keeps the high-quality paths on the left and right. Well, Table 1 reveals the actual text structure behind those strategies. In the first step on the left, the system injects specific instructions, shown in teal, telling the model to identify risks and cascading effects. Then, in blue, it provides a mandatory sentence starter, here the phrase, if current levels of plastic waste continue, which effectively steers the output. The model then takes over to complete the thought, shown in orange. As we move to the final step on the right, you can see how these interventions stack up, layering multiple guided reasoning steps before the model generates the closing answer. So Table 2 results show how these interventions translate into actual performance gains on the novelty bench dataset. The columns track diversity, labeled D, and utility, labeled U, across 3 different temperature settings. Focusing on the middle section for temperature 0.7, the standard train of thought baseline only reaches a diversity score of 2.44. In contrast, the bottom row shows that state of thought surges to 5.02, effectively doubling the semantic variety. Crucially, this variety does not sacrifice quality, as the utility score also climbs to 3.83, which is the highest in the column. While Table 2 established the performance gains, Figure 3 asks whether we can predict those quality outcomes from the actions themselves. The charts display the R-squared values for different prediction models, with the test set performance shown in panel B on the right. Notice the cluster of bars labeled strict. Here, the darkest bar represents the sequential model, which considers the specific order of actions. It reaches an R-squared of nearly 0.6, vastly outperforming the lighter bars that only look at whether an action was present or not. This confirms that the timing of a reasoning step is just as critical as the step itself. Okay. Since Figure 3 proved we can predict quality, Table 3 asks if we can use those predictions to steer generation. The authors create targeted arguments from high-scoring patterns and compare them against 3 baselines: random, topic presence, and the original top 5%. In the win rate column, the targeted approach dominates the random baseline, winning 77 to 81% of the time. It also consistently beats topic presence, confirming that structural guidance matters more than just keywords. Most impressively, in the strict section, it even edges out the original top 5% with a 51.7% win rate, effectively generating new state-of-the-art responses on demand. Wrapping up, 2 takeaways stand out. Structured, interpretable actions can significantly outperform random sampling for diversity, and they make the reasoning process transparent. By treating reasoning steps as data we can analyze, this framework transforms black box generation into a controllable optimization problem. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.